Example 4. Now, it's almost the same problem. You have to use inverse norm. Why? Because now you want to find C such that the area is 0.92. Again, I stress how useful is this diagram. You want this area to be equals to 0.92. Because you want mod z smaller than, let's take note, okay? It's smaller than, that means between minus C and C, you want this area to be 0.92. Now, does it make sense that, which means you want this to be 0.92 by symmetry, you always must think, because the standard normal has mean equals to 0, probability z smaller than minus c is equal to probability z greater than c. So these two end areas are the same. Make sense? Then how do we find c? You need the inverse norm for sure. Okay? So, first, I will say this. Since these two are equal, and you know the one in the middle is 0.92, and you know the total area is 1. So you will take this must therefore be equal to 1 minus 0.92 divided by 2. Make sense? Wake up, those who are already sleeping. See, in front also can see, my goodness. You take 1 minus 0.92 divided by 2 because these two end areas are the same. Which means this is equals to 0.04. Now we can use inverse norm. Alright, now we can use inverse norm. By using inverse norm, by GC, you can get 0 minus, you got minus C equals to minus 1.75, C is 1.75. Now, for those of us who have the new GC, new OS, as an alternative. New GC OS. That means you use center. I'm going to show all of us this. That means what you are asking the GC to do is, can you have attention please? You want the center area to be 0.92. I'm going to enter this in. Very quickly. Area is 0.92. You want the center area 0.92, symmetrical area. Mean is 0, standard deviation is 1. Now this time you choose center. You press enter. What will you get? You will get minus from minus 1.75 to 1.75. So which means C must be, sorry, oh, your way should be. Okay? That means you see, okay, minus 1.75 to 1.75. But immediately you can jump straight from here right to 1.75. Okay, for those of us who have the new. Okay, now it's important. This example is super important. The highlight of the day. Example 5. Okay, let's take a look. Look up. Okay. I don't think it's difficult. Can you have attention, please? A bit too much talking. Thank you. Look up. Nothing to copy. Can we all please pay attention? Can? Good. Now, I don't think it's difficult. If let's say X is a normal distribution, I mean 10 standard deviation 2, you can easily find this using GC. you realize that if I use a standard normal, mean 0, standard deviation 1, probability x smaller equals to minus 1 is also 0.159. What I'm saying here is, okay, maybe now this time I need to draw something. What happens is this. This is your x. Mean is 10. Got it? Now, to find probability x smaller than 8, actually this is 8. This is this area. Yeah. Okay, continue. Now, what you found here is another thing here. This is z. The mean is 0. Now you want probability x smaller than minus 1. The minus 1 is here. And you realize that this, my diagram very lousy. Okay, like that. Okay, not any better lah, huh? You realize that the area under the graph for these two are exactly the same. Why? Let me explain. First, if you can see, the mean of this is 10, the mean of this is 0. Correct? The probability x smaller than 8 here is the probability that x is 2 standard deviation away, one standard deviation away from the mean. Because this is 2 squared. That means the standard deviation is 2. The probability that I'm going to find here, this area is also the probability that the x value is 1 standard deviation away. Because the standard deviation here is 1. So if you recall, normal distribution is a symmetrical distribution, and to find probability, you find area under the graph. So these two shapes, this one is just 10 units. You translate this whole graph 10 units to the left, and then you scale it, you will get exactly this shape. Does this make sense to all of us? Good? Yes? So even without calculator, you should be able to tell me that these two areas are exactly the same. Got it? Yes? But how do we do it? What if the numbers are not so nice? Okay, let me explain now. So let us use another example. I want another example. Don't need to copy, we just listen, all right? Let's say this is 20 and this is 4 square. This graph will obviously look like this. This is 16, this is 24. Now, can I say this? If I take y minus 20, what do I get? That means I translate this entire graph to the left by 20. What will the mean be? 0. Make sense? The mean will be 0. Then I will divide by 4. I divide by 4 such that now the standard deviation is not 4, but the standard deviation is now 1. So this will actually be exactly what I call the standard normal. I will get a graph like this. Because I translate it, I will get something like this, where I translate it, where the mean is 0, the standard deviation is now 1. So I will minus 20, so this will be y minus 20 divided by 4. Does it make sense to all of us? Yes? Then you ask me, Mr. why go through so much trouble? You can use GCY. Why do you need to minus and then say that it's standard normal? I explain to you later. You realize that in order to solve example 6, we need this idea. Okay, let's solve example 6 now. Okay, example 6. Oh, sorry. So maybe I should go back to the theory above, the standard case here. Can we take a look at this now? Does this now then make sense? All I'm saying is, let's say I have x with mean mu, standard deviation sigma. I minus mu divided by sigma, I will get a standard normal. Does this make sense? Yes? Good? Okay. What do I make use? How do I make use of this? Let's take a look at example 6. Can we all take note here? First thing I would say is cannot use GC. Am I right to say that? Why cannot use GC? Because there is an unknown mu here. I repeat one more time. You cannot use GC because what do you enter into a mu into a GC? Yeah, nothing. So here is a classic case of no choice, but you got to use the idea we just seen in example 5. What is the idea there? First, recall, if I take x minus mu divided by sigma, I will get z. Correct? And where z is the standard normal. What I'm doing here from here to here, I will divide by 10 throughout the inequality, which means this, which is equals to probability 15 over 10 mod x minus mu over 10, smaller than 20 divided by 10. Got it? Yes? Why do I divide by 10? Because I know that the standard deviation is 10. Look here, variance is 100, standard deviation will therefore be 10. Now, let us see what is this now. X minus mu over standard deviation is actually the standard normal. Now, can we use GC? Since now this is equals to this, can we then use GC? I think it's not difficult. We can immediately use GC. Or can we? Because we have a mod. How? If. Start. Sorry. Cannot use GC because we got a mod. Wait, where's my diagram? How come you have diagram, right? Wait. Oh, yeah, got diagram. Yeah. You want mod z to be between minus 1.5 and 2. Actually, it's this. That means you want z to be between 1.5 and 2 and z to be between minus 2 and 1.5. Which means you want 2 times, which means you want this before we say 2 times first. That means you want x, z between minus 2 and minus 1.5 and 1.5 and 2. Does it make sense? And by symmetry, because by symmetry, from here to here is by symmetry. By symmetry. Since the z is symmetrical about 0, then this is equals to 2 times of probability z between 1.5 and 2. Then this one to this is by GC. I want to summarize the most important point today is this. Mu is not given, you will just have to standardize. Mu or sigma. Correct? If mu or sigma is not given, you cannot use GC. Die, you have to standardize. Got it? Okay, let's very quickly finish example 6. Now find the value of mu given that this. Now this is given, it's given. then you actually want to find mu. Very simple. First thing we do, what do we do? Okay. Can we do me a favor? Can we write down the first line? Write this down. What would you do if you don't have mu? Just write down first line lah. Help me lah. Can? Write down something. I give you a clue. Standardize. Standardize is what? You take x, you minus the inequality line by mu divided by sigma. Fine. Pencil also can. Alright? You are minus mu on both sides of the inequality. Here, what you do is do the same on the left and right of the inequality. You minus mu, divide by 10 on both sides of the inequality. That means this probability x minus mu over 10. Then you don't write greater than 21 Huh? Greater than 21 minus mu over 10. Must be equal to 0.242. Then again I say, what is z? X minus mu over sigma is actually z. Correct? Recall. Then this is obviously probability z greater than 21 minus mu over 10 equal to 0.242. Now, can we use inverse norm now? Yes, because now z is a known distribution. Mean 0, standard deviation 1. But for the benefit of everybody, we better change it to a lower bound area. Correct? Because now this upper bound area is 0.242. You change it to a lower bound area. That means this probability z smaller than 21 minus mu, over 10 is equals to 0.758. Then we can use inverse norm to find GC. By using GC, you get 0.6998. Then, blah, 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 you will get mu equals to 14. Perfect timing. I release you all on time.